In this video, we're going to look at some exam questions to do with half-life, which is within the radioactivity topic. Now, the key thing about half-life is in the name. It is called half-life for a reason. It is all about halving. You might be trying to find out how long it takes something to halve, or how many times it's halved, or how much is left after it's halved 10 times. But the key phrase is half. So we'll have a look at some questions and they'll build up in difficulty. So the first one, we've got a graph. The sample was collected from the desert in 1992. Determine the activity of the tritium in the sample in 2007. And we've got activity on the graph, and we've got time in years on the graph as well. So what we need to know is, well, how many years has it been? So from 1992 to 2007, now I can do that in my head, but if you do need a calculator, you can do. You could do 2007 minus 1992, and it'll tell you the difference is 15 years. So we need to know the activity after 15 years. So I can read that off the graph. If I just zoom in, so 15 years, go up to the graph, staying on the same line, takes me to there, across, that brings me to here. So now I just need to know what this line is. Now, if I'm not sure how to read the y-axis, I can just guess what the little squares represent and check I'm right. So I'm going to assume they go up in ones, but I'm going to check. So 30, 31, 32, 33, 34, 35. Right, it doesn't go up in ones because that's not 35. It must go up in twos. So 30, 32, 34. So after 15 years, the activity is 34. So it's reading from a graph. Now the question then continues, how much time did it take for the activity of the tritium in the sample to decrease from 80 to 40? So if I go back to the graph, well, it starts at 80, so that's time 0. To go to 40, I'll have to go across from 40, which takes me to there, and I end up there. So I'm exactly halfway between 10 and 15. So exactly halfway between 10 and 15, 12.5. So it took 12.5 years to go from 80 to 40. And then comes the question about the topic we're talking about. So what is the half-life of tritium? So they are asking, how long did it take to halve? Notice I am given no space for any working out, no lines to do any sums, nothing. That means I already know the answer. So how long did it take to halve? Well, going from 80 to 40 is halving. So it took 12.5 years to go from 80 to 40. It took 12.5 years to halve. So as soon as I see half-life, how long did it take to halve? That's what I'm asked. We'll look at another one. So the sample polonium-210 decays. Now don't get confused by this number. It's just part of the name. That whole thing, polonium-210, is the name of the element. That number means nothing other than it being part of a name. The graph shows how the percentage of polonium-210 nuclei remaining varies with time. And we're given another similar graph. Determine the half-life of polonium-210. I am being asked, how long did it take to halve? So it started at 100 at time 0. Half of 100 is 50. I go across. I go down, making sure I stay on the same line. If I wasn't doing this on the computer, I'd be doing it with a ruler to make sure I stayed on the same line. And I end up here. So I'm going to need to work out what each of these squares represent. So I'll do a guess and I'll check. So 100 I'm going to guess 10, so 110, 120, 130, 140, 150. Right, that can't be right because 150 is over here. So I'll go up in fives. 105, 110, 115, 120, 125, 130, 135. And just to check, 140, 145, 150. Right, so yeah, I'm right. It goes up in fives. So it took 135 days to halve. So as soon as it asked me to determine the half-life, I'm finding how long it took to halve. Now let's look at a different style of question. So another isotope of polonium, polonium-206, remembering that number is just the name. The name is polonium-206. It has a half-life of 8.8 days. They have told me the half-life. A 5 milligram sample of polonium-206 was left to decay. Calculate what mass of polonium-206 remained after 44 days. So I'm being asked to work out how much is left after 44 days when we had 5, and every 8.8 days it halves. So if it halves every 8.8 days, how many times is it going to halve in 44 days? So I need to know how many times does 8.8 days fit into 44 days. So I'm going to do 44 days divided by my 8.8 days to find out how many times is it going to halve. So on my calculator, 44 divided by 8.8 is 5. It is going to halve 5 times. Because every 8.8 days it halves, it's going to halve 5 times. So if it's going to halve 5 times, we're starting with 5. Type that into my calculator as we go. 5, halve it once, halve it twice, halve it 3 times, halve it 4 times, halve it 5 times. I want this number. So halved once is 2.5. Halve it twice is 1.25. I am doing this with my calculator. Halve it again is 0.625. Halve it again is 0.3125. And halve it one more time is 0.15625. The question doesn't say anything about significant figures, so that can be my full answer. So that's how much left after 44 days. It's halved 5 times. Now, you don't have to write out every one like I have. You could just type into your calculator 5, divide 2, divide 2, divide 2, divide 2, divide 2, 1, 2, 3, 4, 5 times, and it would actually come out with the same answer. You don't have to write all that out, but it helps me check I've done it the right amount of times. Right, they've put this one in a different situation. The student rolled 144 dice and removed all those that landed on the number 6. The student rolled the remaining dice again, removed all those that landed on the number 6. When the student had rolled 20 times, there were 9 dice left. Calculate the most likely number of times that the student had rolled the dice before the number of dice had halved. This is a half-life question. So we are being asked to find the half-life, but in dice rolls, not in normal time. So remember the trick to any half-life question: halve, keep halving. So I start off with 144. So type that into my calculator. Let's halve it once. Gives me 72. Halve it again. Gives me 36. Halve it again is 18. Halve it again is 9. Right, it mentioned 9 in the question. So to go from 144 to 9, it halved 1, 2, 3, 4 times. So that's 4 half-lives. It's halved 4 times. That's 4 half-lives, which was 20 rolls. So if 4 half-lives is 20 rolls, then I can find out what 1 half-life is by dividing 5 rolls. So 5 rolls is 1 half-life. So the number of dice rolls it took to halve is 5. Bit of a weird question. It doesn't mention sort of radioactivity, but I actually got rid of the questions before, which were all about radioactivity. So students did know this was a half-life question. Right, another one, again presented slightly differently. The half-life of carbon-14 is 5,730 years. So it takes 5,730 years to halve. Carbon-14 is used for carbon dating. Carbon dating can tell us how old some objects are. A skeleton was carbon dated. The results showed that there was only 12.5% of the original amount of carbon-14 left in the skeleton. Calculate the age of the skeleton. So they've presented this differently by putting it as a percentage. So you always start off with the full amount, 100%. Let's work out how many times it halved to get to 12.5. So half of 100, 50. Half of 50, 25. Half of 25, 12.5. It's halved 1, 2, 3 times. So 3 half-lives. 3 half-lives. Well, 1 half-life is 5,730 years. So 3 half-lives must be 3 times that. So in my calculator, 3 times 5730 equals 17,190 years. So to go from 100%, 12.5%, it took 17,190 years. So that must be how old the skeleton is. Right, we'll look at one